Okay, today's video is all about theoretical and experimental probabilities. So I'd like you to have your spiral notebook, and also if you could pause the video and go get yourself a coin. Any fair coin would be fine, as long as it has a heads and a tails on both sides. Penny, quarter, half dollar, whatever you have will be great. Go ahead and grab that as well, because I'm going to have you be doing an experiment today at home. So go ahead and pause the video if you need to, and then come on back and write down these two vocabulary words. All right, theoretical is in theory. Theory means, gosh, if I'm thinking about this, what is supposed to happen? What's supposed to happen? And the official formula for this is you've got your favorable outcomes, things you want to happen, over your possible outcomes, all the things that could happen. Okay? And then experimental probability, and you'll also hear that called relative frequency. Goes back and forth between the same two names, means the same thing. So you're going to hear me and see the words going back and forth to get you used to the two vocabulary words. It means from the experiment. That's why I like to use experimental probability, because it makes more logical sense in terms of the definition. What does happen? You're doing an experiment. What happens after you do the experiment? So your official formula is, the numerator is, how many times did it occur? Over how many times did you do the experiment? The number of trials. Make sure you have all of this information here, and then we're going to walk through a few problems together before you conduct your own experiment. All right, go ahead and pause the video, copy down what you need to copy down, and then there's some information here we're going to fill in together. So go ahead and pause the video and then come on back and listen very carefully as I explain how we do this. All right, great. So we have Tanya throwing some basketballs, and as you can see, she's done 25 attempts at getting the basketball in the net, and 18 times it went in. All right, so theoretically, what could happen when she throws the basketball? It could go in the net, or she could miss it, right? There's various ways to miss, as I know, because I'm not a very good basketball player. But there's two things that could happen. You could miss it, or you could get it in. So of the possible outcomes, we're looking to see if she can get it in the net. So two things could happen. We're looking to see if she could make the shot. So theoretically, making the basketball shot is a 50-50 chance, right? 1/2 is the same as 50%. All right. Now, she actually did the experiment. She went outside, she played some basketball, and she did it how many times? 25 times. And how many times did she get it in? That's what we're looking for. We're looking to see if she could get it into the net. She got it in 18 times. This is going to be a very quick review. How do we change a fraction to a percent? Do you remember? You want to change, you can use your calculator and divide and then multiply 100. You could do 18 divided by 25 and then times by 100. That will give you your percent. You can also change, does 25 go into 100? Sure. Times by 4. Whatever you do to the bottom, you do to the top. And 18 times 4 is indeed 72, right? And therefore, 72%, remember percent means out of 100, so it would be 72%. Wow. Theoretically, she should be able to get it into the net 50% of the time. But she must be a really good shot, because she got it in 72% of the time. So she is a pretty good basketball player. She's getting it in more times than what we're expecting her to do. Maybe some of you are really good basketball players too. All right, go ahead and pause the video and jot down some information about number 2. Write down the question and some of this other information. We're going to go back and fill in the empty blanks in just a moment. Go ahead and pause the video if you need to. All right, we're looking at rolling a number cube, which is the same as a dice. Rolling a number cube and getting a number greater than 2. Notice greater than 2, right? So we're not necessarily, well, if we roll the number cube, of course, we can get a 1, 2, 3, 4, 5, or 6, right? These are the possible outcomes. We call this our sample space, curly brackets, okay? All right, so our sample space tells us all the things that could happen. Possible outcomes, there's 6 different numbers on the number cube, so there are 6 different numbers that we could roll. right? Okay. And what we're looking for is we roll the number cube and we get a number greater than 2. So we're not looking for 2, we're looking for 3, 4, 5, and 6. Greater than 2. So there are 4 numbers that are bigger than 2. 3, 4, 5, and 6. So our numerator is going to be 4. Those are the 4 numbers we're looking for. Okay? Go ahead and reduce that fraction. Great. Did you get 2/3? All right. 2/3 is what percent? See if you can figure that out. Maybe you already know it. I know that one. My thirds, I know. 1/3 is 33%. 2/3, 66%. It's actually a repeating decimal there. All right, so there's a 66, a little bit more than that, % chance of getting a number bigger than 2. All right, let's say you did the experiment. You rolled a number cube 10 times. And this is what you got when you rolled that 10 times. You got a 5, 6, 1, 2, 6, 4, 3, 5, 3, and 6. All right, let's write the experimental probability that goes along with those trials. See if you can do that ahead before I go through the answers. Can you figure out how many trials we did? And can you figure out how many times we got what we're looking for? All right, we tried it 10 times. There was 10 trials. And of those 10, we're looking for numbers 3, 4, 5, and 6. So we've got 1, 2, 3, 4, 5, 6, 7, 8 times we got those larger numbers. So we've got 8/10. Go ahead and reduce that fraction. Whenever possible, you should be reducing your fractions. So that means 4 out of the 5 times that you roll the number cube, you're going to get a big number. Wow. What percent would that be? 80%. 80%. So if we're supposed to get it 66% of the time, but you rolled the number cube and you did it 80% of the time, fabulous. If you were playing a game where you needed some really big numbers to win, you would have a good chance of getting the number that you're looking for. Chance. Probability is all about chance. All right, the last thing I'm going to have you do is take your coin that you have taken out there. Remember, any kind, it doesn't matter if it's a quarter, a penny, or $50, whatever. And you're going to be flipping that coin, and we're going to write down the probability of you flipping heads. So first I want you to find the theoretical probability of getting heads. Okay? Theoretically, how often should you get heads? Okay? I want you to actually do the experiment 10 times. Flip the coin, let it land on a flat surface, check to see what it is, and record that in your notebook. Do it again and record it 10 times. Okay? Then I want you to find your relative frequency to go along with your experiment. In other words, what's your experimental probability of getting heads? And then I want you to compare your 2 frequencies. Compare your theoretical to your relative frequency and see how you did. Did you flip heads more often than you should have, or less often, or the same amount? And then when you come in class, we're going to talk about those and see how they compare. How they compare to your partners and your group mates, as well as to the class as a whole. I'll see you soon. I'm looking forward to seeing your results.